Okay, in this video we're going to look at how to find the equation of a circle when given various different pieces of information. So the first thing we're going to look at is finding the equation when we are given the center point and the radius. So this is probably the easiest version. So when we are given the center point, so the question we're going to look at, we're going to look at exercise 13 for these questions. And that's on page 340. And for this question, we're going to look at question number 1, part B. So in question 1, part B, we are given the center of the circle, which is the point 1/3, comma, minus a half. And we are told that the radius is equal to square root 7. So when we're given this information here, so remember we have two possible equations of a circle to choose from. X minus h to be squared plus y minus k to be squared equals r squared, or the general equation of a circle, which is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So you have to choose one which suits the information that you are given. So in this case, where we are given the center and the radius, the easiest option is x minus h to be squared plus y minus k to be squared equals r squared. We can simply fill this information in directly. So we're looking at x minus 1/3 to be squared plus y plus a half to be squared equals root 7 to be squared, which is 7. Now I wouldn't leave it as this, I would actually multiply it out and simplify it. So when we multiply everything out here, we're looking at x squared minus 2/3 x plus 1/9 plus y squared plus 1y plus a quarter, and then we're going to bring the 7 across, minus 7 is equal to 0. Tidying everything up, we have x squared plus y squared minus 2/3 x plus 1y and 1/9, 1/4, and minus 7 gives us minus 239 over 36 equals 0. So you can leave it in this format here with your fractions, or else you can multiply everything across by 36, and in that case you get 36x squared plus 36y squared, etc. All right, so that is probably the most easiest type of question that you will get in terms of finding the equation of a circle. And that's scenario 1, where we're given the center and the radius. So a second scenario that we're going to look at here is when we are given 2 points on the circle that form the ends of the diameter. So imagine our circle. We know that this line here is the diameter of the circle, and we are given this information here. So the question we're going to look at here is question 1, part C. And we are told in question 1, part C, that the points P, which is minus 1, 2, and Q, which is 3, 4, are the ends of the diameter of the circle. So our line PQ goes straight across the middle of the circle. Because it's the diameter, we know that the center lies on that line, and the center of the circle is the midpoint between P and Q. Because it's the diameter, that means that the diameter is twice the radius, and that means that the center is our midpoint. So in order to get the equation of this circle, the first thing we need to do is find the center of the circle. So we find the midpoint of PQ. So the center midpoint formula comes from the log tables on page 18. We add the x coordinates, divide by 2, so that's minus 1 plus 3 divided by 2. And add the y coordinates, divide by 2, so 2 plus 4 over 2. So that gives us a center point of 1, 3. We know that the radius is going to be half of the distance from P to Q, because if P to Q is the diameter, the radius is half of that. So the radius is half. And again, we use the distance formula here, again from page 18, the log tables. So that's looking at x2 minus x1 to be squared, etc. So that's 3 minus 1 to be squared plus 4 minus 2 to be squared, and half. So that gives us half of 2 root 5, which gives us a radius of root 5. Putting it into the equation of a circle then, remember a center point is 1, 3, so we have the same scenario as before as question 1 part B. We have the center and the radius, so the easiest format is x minus 1 to be squared plus y minus 3 to be squared is equal to r squared, which is 5, and multiplying it out, we have x squared minus 2x plus 1 plus y squared minus 6x plus 9 minus 5 is equal to 0. And tidying everything up, we are looking at x squared plus y squared minus 2x, sorry, that should be minus 6y there. Minus 2x minus 6y, we have 1 and 9 is 10 minus 5 is 5 equals 0. And that's the equation of our circle. The third scenario that we're going to look at in this video is where we are given 3 points on the circle. So the question we're going to look at for this one is question 1 part G. So in question 1 part G, we're told that we're dealing with a circle which passes through the following points. It passes through the point P, which is the point 5, 1, the point Q, which is the point 4, 2, and the point R, which is the point 2, minus 2. Now for this question, we have no information whatsoever about the center of the circle. Therefore, we cannot use x minus h to be squared plus y minus k to be squared equals r squared. We don't have the information to be able to sub into it. So we are left then with the general equation of a circle, which is x squared plus y squared plus 2gx plus 2fy plus c is equal to 0. So what we need to do is we need to find the value of g, f, and c. In order to do that, we take each of our points and substitute the x value and y value into our equation, and we are left then with an equation in g, f, and c. So first of all, if we look at the point P, which is the point 5, 1, we are looking at x is 5, so anywhere we see an x in our general equation of a circle, we can replace that with a 5. 5 squared, anywhere we see y, we can replace that with a 1. So that's 2g by 5 plus 2f by 1 plus c is equal to 0. And tidying it up and multiplying it, so we have 10g, we have 2f plus c. Now when we're forming equations like this, we always want the variables on one side and then the numerical quantities on the other. So we have 5 squared is 25 plus 1 squared is 26. 26 comes across and becomes minus 26. So that's equation number 1. So you can see here, what we're going to end up with is 3 separate equations in terms of g, f, and c, and then we can use our simultaneous equations from algebra to solve. Looking at the point Q then, Q is the point 4, 2, again subbing it in, 4 squared plus 2 squared plus 2g by 4 plus 2f by 2 plus c is equal to 0, giving us the equation 8g plus 4f plus c. 4 squared and 2 squared is 20, so that is minus 20, so that is equation number 2. And finally, point R, which is the point 2 minus 2, will give us 2 squared plus minus 2 squared plus 2g by 2 plus 2f by minus 2 plus c equals 0, giving us the equation 4g minus 4f plus c is equal to minus 8. So here we have now our equations 1, 2, and 3 in terms of g, f, and c. So using simultaneous equations then, first thing we need to do is pick one of the variables to eliminate. We can either pick the f or the c. In this case, if we pick the c, we have a single c here, so we just need to pick 2 pairs of equations to eliminate the c from, or else you can eliminate the f because we have plus 4f and minus 4f here. We have plus 2f and minus 4f, so we can eliminate either or. Now, so let's go with c for the moment. So what I'm going to do is I'm going to subtract equation 1 from equation 2. So we're going to look at that first. So 2 minus 1. So equation 2 is going to stay the same. 8g plus 4f plus c equals minus 20. I'm going to subtract equation 1, which means we change the sign. So minus 10g minus 2f minus c is equal to plus 26. And from that, we will get the equation minus 2g plus 2f is equal to 6. So that now is equation number 4. Then so we now have one equation and two variables, we need another. So we need to pick a different pair of equations to work on this time. So I'm going to pick equation 2 again, and this time I'm going to subtract equation number 3. So writing down equation number 2 again, 8g plus 4f plus c is equal to minus 20. I'm going to subtract equation 3, so that's minus 4g plus 4f minus c is equal to plus 8. The c's will eliminate each other there, so we are left with 4g plus 8f is equal to minus 12. Now, what I can do here, because looking at my two equations, the easiest one to eliminate will be the 2g, or the g here, because we have a plus and a minus. So you can either, because all of the coefficients here are divisible by 2, we can divide across by 2 first of all here. So you leave us 2g plus 4f is equal to minus 6, and then simply add the two equations together. So we have 2g plus 4f equals minus 6, giving us 2f and 4f is 6f is equal to 6 minus 6, which is 0. So from that we get our first variable, f is equal to 0. So I'm just going to move my board across a little bit so I have some extra room to work. So now that we have f is equal to 0, we can go back to one of our equations. So maybe if we go back to this one here, 2g plus 4 times by 0 is equal to minus 6. That means 2g is equal to minus 6, therefore g is equal to minus 3. And going back to one of my equations 1, 2, or 3, so if we go back to equation 1 here, 10 times by g, which is minus 3, plus 2 times by f, which is 0, plus c is equal to minus 26. And therefore we have minus 30 plus c equals minus 26, giving us c is equal to 4. So now that we have our equation solved for f, g, and c, we go back to our general equation of a circle. When we input all our information, it's going to be x squared plus y squared plus 2gx, so that's minus 6x, 2fy is 0, and then plus c, which is plus 4, is equal to 0. So that is the equation of the circle, given that it passes through points P, Q, and R. So you set up a system of simultaneous equations. All right, thank you.